You can see we have three letters here, U, V, and S. We're looking for A. So therefore, the formula we should use is phi squared equals U squared plus 2AS. Okay, so for phi squared, you're going to enter in 10 squared. For U squared, you're going to enter in 4 squared. And then it's going to be 2 times A times your 500. Okay, so it's 10 squared, which is 100. Bring it over to 16, so it's minus 16 equals 2 times A times 500. So what's that going to be? That's 100A, isn't it? Oh, sorry, 1000A. And then 84 equals 1000A. And what's 84 divided by 1000? Broken down to its, huh? 21 over 50? Okay. Yeah, divided by 250, was it? Yeah. 21 over 250. The units in this case are meters per second squared. Is that okay with you guys? All right. Next thing we're going to do is we're going to start off with these 4 formulas, okay? And we're going to look at one of the more formal questions on the board. So what you have here is a car driving on a straight road accelerates with an acceleration of 3 meters from rest to a speed of 24. Find the time taken and the distance covered. So at the start of each question, what we do is a little list called UVAST. Okay, so that's the way I always line them up like this, and then I make a list of which ones I have to begin with. When it says the word rest, what does that mean about your initial speed? 0. Your V value? V. Your final velocity? 24. Your A value? 3. Your S value is question 2, and your T value, your T value is question 1, and your S value is question 2. Off you go. Pick a formula and use it. All right, have U, V, and A. Looking for T, I suggest using the first formula. So 24, V equals U plus AT, 0 plus 3 times T. So 3T equals 24, is it? And then your time is 8 seconds. Cool. All right, find your S value now. All right, guys, so you have 2 choices here regards finding your distance, okay? Well, maybe even 3 choices, is it? No, two choices. S and T. Actually, let's try out the second one first, right? So we're going to try out. We'll try out each formula individually, and we'll see what goes on. All right. So the first one is S equals, what's this going to be? 0 plus 24, yeah. Divided by 2 multiplied by T, which is 8. 12 times 8, 96, right? That worked perfectly, 96 meters, no bother. Next one, S is equal to U, T plus a half AT squared. 0 times 8 plus a half, 3 times 8 squared. 8 squared is 64, half 64 is 32, 3 times 32, once again gets you your 96. You happy enough with that? And finally, the last one, phi squared equals U squared plus 2AS. You can just have 24 squared equals 0 squared plus 2 times 3. 24 squared, anybody? I think it's 576, is it? So that's a 24. And that is, over this side, we have, what's a 2AS? So it's 6S. And then 576 divided by 6 is 96. So you can see that when you have 4 out of 5, your methods can then diverge, can't they? But when you only have 3 out of 4, generally there's one way of doing the question. That makes sense? All right. Next question. Go on, give it a go. So what we have is a 50, a 70, a 300. You can find the T first, then find the A. I'll just do it in order, alright? So if you can, just do whichever one comes first. So I go for A here. So because I'm looking for A and I have phi, U, and S, I'm going to choose the fourth equation. Somebody else may have found T first and then did it that way. That's okay as well. So what we're going to get is 70 squared equals 50 squared plus 2 times A times S, which is 300. Now 70 squared is 4,900. Take away 2,500 for the 50 squared, and that should equal 600A. And 2,400 divided by 600 is what, guys? Oh, sorry. So when you divide 2,400 by 600, you get a value of 4. I don't know what's up with my writing here today. 4 meters per second squared, all right? To find the T value, I would recommend you don't want to get the T value using this. Can anybody tell me why? You can, but you really don't want to do it. Why would you not want to use equation 3 to find the T value? Anybody tell me? Hands up if you can figure it out. Yes. And it's a quadratic equation, which means you'll have to use the minus b formula, and you really don't want the hassle when there's better options available. So what's the better option for a T value? Equation 1's nice, or equation 2. Okay, so I'm going to try equation 1 really quickly. So phi equals u plus at. So what I'm going to say is, what's it, 70 equals 50 plus at, which is 4 times t. Did everybody get 20 equals 4t? When you bring the 50 over to your side. And then t therefore equals 5. Alright. Should we make this a bit harder? Or is this level too easy at the moment? A bit harder? Okay, let's make it a bit more difficult. Let's skip 7. Let's go to 10. Off you go. Not that they need it. Anyways, 72 kilometers is 72,000. An hour is 3,600 seconds. And we get 20 meters per second. Great. Likewise, 48 kilometers an hour is 48,000 divided by 3,600. Pretty sure that's 15 meters per second. Let's be sure to be sure. Oh, maybe I'm wrong. I'm wrong about that one, haven't I? It's 13 and a third. 48,000 divided by 3,600. So 13.3 or 13 and 1/3. Best to keep it in fractions, guys. Fractions are more accurate than decimals, okay? So keep it as a mixed fraction or a top heavy fraction even. Actually, top heavy is probably the best. 40/3. So you're going to have to get used to top heavy fractions. Don't use decimals where possible. A distance of half a kilometer is 500 meters. Okay, now we can set up my U-vests. So U is, you need your formulas, don't you? There you go. Let's put them up there. Now the answers are ready. V is 40/3. It's a deceleration. Starts off at 20. S is 500. You want to find the A value. So my suggestion is equation 2.4. Okay, because you have 3 out of the 4 letters. So what we're looking at here is 40 over 3 squared (20 squared) plus 2A. If you hear me coughing, by the way, I got tested. Now, 1000A is 1600 take away 400. It has to be a negative number. Why does it have to be a negative number? You're getting slower, so you have to be so minus 2000 over 9. And then when you divide that by 1000, it's simply going to be minus 2 over 9 meters per second squared. We all good? If the train continues to decelerate at this rate, find out how much further it will travel before it comes to rest. So you're going to set up a second set of data, okay? Now, in this second set of data, you're going to do another UVAS system. I'll do it in green. You still start off at 20, but what's your V value this time? If you come to rest. Huh? 0 over the V value. Does your acceleration stay the same as the last question? Yeah, same train, same situation. And you're asked for how much further it will travel. So is that an S or a T question? S, a direct S, and then take your 500. It will be a bigger number than 500. Can anybody tell me why? Because you're traveling further before you come to rest. So the S value will be bigger, and then you just take away 500 to see how much further you actually went. Off you go. Got an S value of 900 meters, which means how much further did you travel? 400 extra meters. That's lagging. Okay, guys. So you have two of them that are 400 meters apart. So if you imagine this line here, separating them, we have X and Y. This is X and this is Y. Now they're both moving towards each other. You say that one of them's going 3, acceleration 4, and the other one's going 7 with acceleration 2. It's very hard to know which one is going, it's very hard to know where they're going to meet, isn't it? It won't be dead center. So there's 2 scenarios. Okay, they could meet dead center, that's highly unlikely. They could meet closer to X or closer to Y. Honestly, off the top of my head, I don't know which one it is, but it doesn't matter. So all I'm going to say is that here's your meeting point here. See the red zone? Now, we're going to set up 2 different sets of data. This is going to be known as S1, the distance X travels before a collision occurs. This is going to be known as S2, the distance Y travels before a collision occurs. You need 2 sets of UVasts, so get your UVasts written down. You're going to need 2 of them this time, not 1 of them. Okay? So UVAST. Now, in X's case, the U value is 4. We don't know A, but we know that's 3. Doesn't give us much to work with. And then what about the other side? We know U is 7 and A is 2. Now, unlike previous questions, we need 3 out of 4 data points, don't we? We only have 2 out of 4, don't we? So there's a sneaky trick in here, and here's the sneaky trick. Yes? No need, because it's just about overall distance covered. But I get what you're saying. Just leave it. Oh, sorry. Oh, sorry, my fault. A is a deceleration, is it? Oh, sorry, my fault. So 3 and 4, is it? Yeah, my fault. So that's 3. Thank you for spotting that. And 4. Is that everything happy now? Okay, perfect. Now, always good to double check before you commit to the question, okay? Don't do an exam where you realise you put the wrong data in straight away, so double check, okay? Now guys, here's the sneaky bit. What can I say S1 plus S2 is? 400. And what are we looking for? We're looking for time, aren't we? So I have U, I have A. Now, what can we say about both times? Do both particles start at the same time? So they're both the same value. So the T values are identical. Okay? So it's a T question, so we're going to have to use T as well. So we know we're using U, A, and T. What about the S's? We know that S1 plus S2 is 400. That means we should use S. So what formula do you think we're going to use for this entire question now? S equals UT plus a half AT squared. You need to get S1 using the blue data, and you need to get S2 using the black data. Okay? So let's find out really quickly, all right? I'll start off with black here, okay? So what can we change S1 with? What's U? U is 3. The T value? Just T. Plus a half. What's the A value for the X value? 4. And then what's the T value? We don't know, so it's just T squared. And what about the S2 value? What's U? 7. And then the T value is T. And then a half. What's the A value? 2. And then the T value? T squared. And what do both of them added up together equal? You're about to get yourself a quadratic equation to solve to find the T value. Okay? So off you go. So you use the minus b formula if you want, but I'm just gonna factorize it into this. Will this work? Yeah, it will work. T into 3. Whoa. Oh yeah. 3t plus 40. Minus 10. 3t plus 40. T can't be negative, so therefore it has to be a positive answer. So I'm hoping you all get t equals 10. It's got to be the first bracket. T minus 10 equals 0. T equals 10. All right. Okay. A particle starts from rest with uniform acceleration 2 meters per second. Calculate the following given your answers as rational numbers fractions. So we're going to get 30 kilometers an hour, which is 30,000 meters. And you're going to divide that by 3,600. So 30,000 divided by 3,600. (25/3). 25/3 meters per second. Okay. We're going to U-vast this situation. We start from rest, which is 0. We end up with 25/3. Our A value we know is 2. Then we're after the T value, so we're going to use phi equals U plus AT. And what we're going to get is V equals alright, so 25/3 equals U, which is 0, AT, which is going to be 2 times T, then divided by 2, and you get 25/6. Is that okay with you guys? 25/6? Awesome. How far from its starting point will the particle be when its speed is 60 kilometers per hour? How far from the starting point? So if 30 is 25/3, 60 will be 50/3. So we're going to start again with the U-vast. Oh, sorry. And we need 60. So the phi value has changed to 60 is what we're getting. So U is 0, phi is 60, A is 2. So and we're going to use we're trying to find out what S is. So my suggestion would be phi squared equals U squared plus 2AS. Okay, so phi squared is 3,600. U squared is still 0 squared. 2AS, so 2 times 2 times S. Then we get the S value there. What you get? Okay, yeah. 3,600 divided by 9, or so divided by 4. S value is 900. Okay. We all right with that? Right. Up. Your particle is then brought to rest in 2 seconds, or in 2 meters. Sorry, excuse me. So, UVAST. What's your starting off velocity? It was 60 kilometers an hour, wasn't it? So you get to 60 kilometers an hour, then you jam on the brakes, and you're brought to rest in 2 meters. It's impressive braking. Okay? So your initial speed is now 50 over. Oh, wait. Sorry, guys, I messed that up. The last question. It's not 60, is it? It's 50 over 3. Sorry, my fault. I put in 60 kilometers an hour when it's meant to be 50 over 3. So I got that one wrong. So it's 2,500 divided by 9 equals 4s. And then s will equal 2,500 divided by 36. Do you have the number for that? 2,500 over 36? Fractions if you can. Top heavy fraction. Perfect. Oh, so that's what you said. My fault. 625 over 9 was how much distance it required to, was how far it travels from the starting point to reach a speed of 60 kilometers an hour, which is 50 over 3 meters per second. Okay, in the next question, you start off at 60 kilometers an hour, which is 50 over 3. Your final velocity is 0 because it brings you to rest. Your S value is 2 meters. Okay, your job is to find out your A value. My suggestion for this question would be phi squared equals u squared plus 2as. You have 3 out of the 4 symbols, and you should be able to complete that quite quickly. So 0 squared equals 50 over 3 squared plus 2 times a times the other 2. And then you get 2,500 over 9 plus 4a 0. 2,500a over 9 equals 4a. Does anybody know what 2,500 divided by 36 is? Top heavy fraction? Anybody? Do you got that for me, Oscar? Again, yeah. So your deceleration is minus 625 over 9. That's 2. All right. So when you go home tonight, what you're going to just do there is 1 second. That's only a quarter, is it? Or is that 5 to? All right, grand, but then I'm not in a hurry. All right, so come on. All right, so what you should be able to do when you go home is you should be able to try some of these questions. So I want you to try questions 1, question 3, question 5, question 7, question 9. Oh, sorry, did I get question 9 there? I didn't. Sorry, 1 second. Come on. There's question 9 there. See that? That's question 9. Be on the video later on. You can just zoom in and look at it on your phone. All right, your question 11. Suppose I did 14, so maybe 12 and 13 for you guys. Okay. And